Here are some things that will blow your mind. From a space atomic bomb to life that challenges all the rules. 1. SN2016 APS. In October 2016, astronomers witnessed a star explode in the distant Peacock constellation. But this wasn't any ordinary supernova. Oh no, this baby was 500 times brighter than a typical stellar explosion. It's one of the most luminous events known to man, and it gets crazier. This hypernova could be a dual solar supernova, meaning it's powered by a star that's literally turning into an antimatter factory. That's right, the star's core is squeezing protons and electrons together to make matter and antimatter. The explosion was so powerful that it likely left no particles in the holes. The star literally evaporated. 2. Myxozoa. Meet the ultimate parasite. This organism is so bizarre that scientists are forced to rethink the meaning of the word life. First off, these cells are smaller than most. Just 10 micrometers across, they defy our understanding of multicellular complexity. But get this, they're predators. These microscopic monsters use their tentacles to capture other cells and devour them whole. So how did they evolve? Well, their jellyfish ancestors lost 99% of their genes in a massive genomic shock. Some researchers speculate that these creatures may be evidence of alternative biochemistry. Could there be life forms that don't rely on DNA or RNA? Are we seeing shadows of alien biochemistry right here on Earth? 3. The lost magnetosphere of the Moon. We all know the Moon as a barren, lifeless rock. But a new analysis of Apollo samples reveals that our satellite once boasted a magnetic field stronger than Earth has today. This discovery upends everything we know about the Moon's history. The field has likely persisted for more than 1 billion years, meaning the early Moon had a molten metallic core with enhanced dynamo activity. Possible atmospheric confinement, a magnetosphere. Protection from solar radiation. But what happened? Some theories point to a giant impact that shattered the core, knocking the Moon out of its molten state. Others suggest that the impact could have been caused by a rogue black hole passing nearby. Either way, this discovery suggests that the Moon was a much more hospitable place in the past. 4. Chariklo. This 250-kilometer asteroid shouldn't exist as we see it. In 2020, scientists discovered two dense rings around the asteroid. Named Oyapock and Kui, they orbit just 7 and 14 kilometers from the surface. By comparison, Saturn's rings extend 70,000 kilometers from the planet. How did they form? One theory suggests a recent catastrophic collision created all this debris. Another proposes the existence of hidden ringed shepherd moons. But the most intriguing idea is that we're re-seeing observations of a new moon for the first time. 5. Neutron stars. These burnt-off rings are the smallest and densest stars in the universe. On the surface, they burn at 1 million degrees Celsius, but it's what's inside that counts. At 600,000 degrees Celsius, protons and electrons fuse into a superfluid neutron soup. Even deeper, matter might look like a quark-gluon plasma, a state last observed microseconds after the Big Bang. Then there's strange matter, hypothetical particles that could explode ordinary matter. And finally, boson condensates, a quantum state that curves spacetime itself, and that's why this matters. These aren't just interesting facts, they're clues to existential questions. Did life elsewhere start by mistake? Myxozoa. Can the world lose its defenses? Moon's magnetosphere. What happens when matter thinks neutron stars? Are we missing fundamental physics? Hypernova? Next, want to learn more? The next decade brings even bolder discoveries. James Webb's hunt for supernovae, Artemis exploration of the lunar core, DARTs, follow-up on asteroid dynamics and next generation. Telescopes probe neutron stars. There's so much more to discover. So keep looking up. Now it's your turn. Which discovery shocked you the most? Let us know in the comments. Thanks for watching and see you next time.